Okay, now we're ready to do 13.5b. I've rebooted the computer and I hope that's helped. It seems to be. So we're going to be factoring binomials that look like this. Not like that. We'll see when we get to it. And this is a really important factorization. It's really easy to forget, and this is the one you don't want to forget. So again, just the introduction. Let v and w be two polynomials. As before, this means they can be single variable terms or integers, amongst other things, but that's what we're going to be looking at mostly. Then if we have w squared minus v squared, then the factorization is v minus w times v plus w. So again, we're talking about factorization. We're going to be given a binomial. Usually the v squared and the w squared, they're not going to have the squares up here. You're going to have to discover what w and v are. And once you do, then we can immediately write the w minus v times w plus v factorization. So this middle right here sign must always be negative. There is no negative or positive check this time. So let's just do the few exercises that we have. And it's going to be pretty much exactly the same as we did before. So this is 3a. So I'm given x squared minus 9. So what we want to do is we want to see, that's supposed to be a question mark there, and that's supposed to be an eraser. We want to see, so that's our we're asking ourselves now. If we can find a w and a v such that this is equal to, man, I'm just messing up, writing things I don't want to write. If this is w squared minus v squared. And if so, then we can write it as w minus v times w plus v. That's our factorization. So again, I look and I notice that x squared is x squared and 9 is 3 squared. So w is equal to x, v is equal to 3. I found my two candidates. I'm done. So the answer is yes. So this is w minus v times w plus v from that formula there, which is equal to x minus 3 times x plus 3. So just for a reminder, I always get these questions, and this is exactly the same as x plus 3 times x minus 3. Because this is one factor, x plus 3 times another. So this is really multiplication. So I write x minus 3 because we have an x there, but it doesn't really matter. So the answer was yes, this has a perfect, this is a difference of perfect squares, so its factorization is immediate, x minus 3, x plus 3. So I defy you to see how difficult it is to use our tic-tac-toe method, or whatever, table method, or whatever, to factor that. And at the very end, I'll actually show you, if you're really enamored of that method, and I'm just going to tell you, people, you really need to memorize this. It will be so useful, and you get a leg up in everything that comes. Many problems will come in intermediate algebra by failing to remember that factorization. even though it will be reintroduced to you. So this is x squared minus 25. So no more W and V stuff. I'm just weaning you off that. So that's the same thing as x squared minus 5 squared. So there are my two things which are squared, x and 5. So that's equal to x minus 5, x plus 5. If at this point you want to come down here and say, well, my w is equal to my x, and my v is equal to 5, and then do w minus v times w plus v is equal to x minus 5 times x plus 5, then you can, but I don't think we need to go into that level of breaking it down. Sometimes a level like that of breaking it down can make something which is really relatively simple be or seem far more complicated. So I have y squared minus 64. So the big thing I look at when I look at this is, number one, this is a polynomial of two terms. It doesn't have a degree 1 term. There is no y. There's a degree 2 term, and there is the last term, which is the constant term. So the point is not so much as the degree, but just what they are. And the big thing is that's a minus. And so I asked myself, what can I do with 64? Is 64 a perfect square? And it is. The square root of 64 is 8 squared. So here I found my candidates. This is y squared minus 8 squared. So that gives me y minus 8 times y plus 8. (3D). I have 4a squared minus 9. Well, here I want to notice that 4a squared is 2 times a squared, and that 9 is 3 squared. So that's equal to 2a squared minus 3 squared. So here's my w and here's my v. So that's equal to 2a minus 3 times 2a plus 3. And we will do 3e. I'm given 49 x squared minus 1. Again, the important thing is there's just two terms, and that is a minus sign there. Well, the square root of 49 is 7. So this is 7x in parentheses squared. And we realize that 1 can be written as 1 squared. So this is 7x minus 1. Because my w is 7x and my v is 1. Times 7x plus 1. And then final, one last one, is 3f. And I'm given 9a squared plus 16b squared. And done. No factorization as a difference of perfect squares. Why? I was done immediately. I know 9a squared is 3a in parentheses squared, and 16b squared is 4b in parentheses squared, but it's no factorization as a difference of perfect squares, and the key reason being is the word right here is a difference. That's not a difference. Even if I do write this as 3a squared and 16b squared is 4b squared, so those are two squares. This is a sum, and we need a difference. So So as soon as you see some other sign besides the minus sign there, it cannot have that factorization. And in this case, it's prime. There is no other factorization that I can do. 9a squared plus 16b squared is a prime polynomial in the variables a and b. Specifically, because we're done, that's all of the examples. Specifically, 9a squared plus 16b squared, let's classify it. It's a binomial. Why? Because it has two terms. It has degree 2, because the degree of a polynomial is the degree of their largest terms. So the degree of the first term is 2, and the degree of the second term is 2. It's in the variables b and a. And what else do I know about it? It is prime. So I think of all of these, they're all important to know. The fact that it's only two terms is important. Degree 2 is important. In the variables b and y, who cares? I mean, because those are, it's what's important here is it's in two variables. Not that the variables are actually specifically b and a, but there's it's in two variables, and that it's prime. At any rate, that's all we have for 13.5 Part B, and I hope you understand this factorization. It's really simple and actually really important.